Hello! So today we're going to learn about the atom. We're going to learn what an atom is made up of, what it is, and the amount of types and different types there are of an atom. So first of all, let's start off by learning what even an atom is. So an atom is the basic unit of matter. So as you may know, matter is everywhere. And matter and atoms are the building blocks for matter. And so atoms are made up of three special items. And those are electrons, protons, and neutrons. So these three have special properties that you can use to identify them. So first of all, let's start off with protons and neutrons. Protons. So protons are very easy to identify. And the most, I'd say, well-known is that they're positively charged. That means they have a positive charge. And if you think about it in a mathematical way, it's like saying it's 1 or 2. It's a positive number. And secondly, its second property is that it's found in the nucleus. So you may be wondering what the nucleus is, so I'll explain it to you in a bit. So the third property is that the number of protons identify the element. So let's say for example hydrogen or H2. It's everywhere, everybody knows it. If you look on the periodic table, you'd see a number next to each element. And that number is known as the atomic number. And the atomic number is the amount of protons there are. So as we're talking about this property, it's basically the atomic number. So the atomic number of hydrogen is 1. That's its atomic number. So you can say, using that information, the atomic number of 1 means hydrogen has 1 proton. And the fourth point is that the number of protons in an element never change. And I have to emphasize never, because they never ever change. You cannot change them, because it's what single-handedly identifies an element. So once we're done with protons, let's move on to neutrons. Neutrons. So before I start neutrons, I have to explain to you what the nucleus is. So you see this right here, right? This is the core of an atom. The core is in the middle. You know what a core is, right? But instead of calling it the core, we refer to it as, in an atom, we refer to it as the nucleus. The nucleus. And the nucleus, it's made up of protons and neutrons. And you see this visual representation right here, right? That's an atom. So that's visually represented by an atom. However, with your eye, you cannot see this. You need a microscope to see this, and it has to be very, very advanced, because atoms are very, very tiny, super tiny. And so when you look at this, protons and neutrons, they're stuck together in the middle, or the nucleus. And protons has a positive charge, right? As we talked about before. What about neutrons? What charge do they have? Well, neutrons, as you might have guessed from their name, well, they're neutral. They don't have a charge. And as a mathematical representation, it's like they're neither a positive number or a negative number. It's like they're 0. It's like they don't have any charge. And a neutron's main purpose is for its mass. The mass of the neutron, it's used to identify the atomic mass of an element. So mass, so let's say found in a nucleus. And the third one is that it's added, I wouldn't say it's its main purpose, but it's added to the protons in order to count the atomic mass. It's the mass of the atom. And it's found by adding the mass of protons and neutrons. And the fourth one is that number of, the fourth point I would say is, the fourth property actually, is that the number of neutrons changes to change the mass of the atom. To change the mass of the atom. So we also refer to this as isotopes. I'll talk about this later. However, these are the properties for neutrons. So now, let's talk about electrons. So electrons are special. They're different from protons and, well, they're kind of similar to protons, but they're a bit more complicated, I'd say. So, 1 minute, let me erase this. So, electrons. So, electrons are negatively charged. So they have a negative charge. From a mathematical standpoint or a representation, if you look, it's like a negative number. It's like -2, -5. And so the second point or the second property I would say of electrons are that the electrons orbit the nucleus. So we talked about this is the nucleus. Where is it? Oh, 1 minute. This is the nucleus. And so the electrons orbit around the nucleus. So you see these green spheres right here? These are orbiting around the nucleus. This is the nucleus. This right here. And so these paths, these orbits, we refer to them as orbits, that they're taking is there's electrons on there. And so these are what the path the electrons take. And so these electrons orbit the nucleus in I'd say a cloud of negative charge. So basically it's orbiting around the nucleus right here. These are electrons. So electrons in a cloud. I wouldn't say it's a full cloud. They refer to it as the cloud of negative charge because electrons are negatively charged. Let me make this a bit more clearer. Negatively, okay, yeah. And so the third point or the third property I'd say is that the mass of an electron, it's so tiny that we don't take into account its mass when we're calculating the atomic mass. We do not take the mass. And so it's like the mass is so small that we don't even care about it when we're calculating the mass of the atom. The electron mass is so tiny. And so the fourth point is that the number of electrons change the charge on an element. So, as I said, I also have to clear up. An element is made up of atoms. So, like for example, oxygen is made up of two because it's a diatomic molecule. We'll talk about that on later episodes. But oxygen, if you take it's O2, right? So it's two like molecules of oxygen. It's like molecules are like atoms. They're made up of atoms. And so elements are made up of atoms, okay? And so the elements can have a positive charge, a neutral charge, and a negative charge. And depending on the number of electrons, the charge changes. So the charge is entirely dependent on the number of electrons there are in that atom or element. And I would say that well, it's depending on this. So the fifth point I'd say basically is that if the atom or element is neutral, oh, 1 minute, neutral, then the amount of protons is equal to the amount of electrons. As you can see, if an atom, like the charge on an atom is neutral, meaning like 0 in a mathematical standpoint, the amount of protons and electrons are equal because they cancel out with their respective positive and negative charges. So that's for electrons. As you can see, there's a lot. That's why I said electrons are a bit more complicated. Or 1 minute. If you'd like to take a screenshot, here you go. And so, up next, let's talk about ions. So, we just talked about charged atoms, right? So, charged atoms, we can also call them ions. So, what are ions, you may be wondering? So let's talk about them. Ions have two types, cations and anions. And cations are positively charged atom. So what does that mean, you may wonder? Positively charged means that there's more positive charges present than there are negative charges. So that means there's more protons than electrons, because protons carry positive charges. So that means there's more protons since a cation has a positive overall charge. And so since you know this, you may already guess anions. They're negatively charged. They're a negative charged atom. And you can guess that since it's negatively charged, there's more electrons. So there's less protons, or positive, and more electrons, or more negative. And so you can see that ions, they divide into two categories. Either cations, positively charged, or anions, negatively charged. So these are the different types of ions, and any atom that is charged with like a negative or a positive can be classified into cation or anion. Next, let's talk about isotopes. So I was telling you before, I was talking about isotopes. So isotopes. You may be wondering what they are. So isotopes, it's the same element, but with a different mass. So you may be wondering what that means, right? So for example, let's take carbon. So carbon has an atomic mass of 12, right? And so there's another isotope of carbon that has an atomic mass of 14. There's multiple isotopes of carbon, right? And so we write it as C12, C14, and etc., right? And so etc. And so C12 and C14, they have the same amount of... So these two have same number of protons and electrons. However, as we talked before about neutrons, if you talk about neutrons, you can see that they're neutral. However, we change the number of neutrons to change the mass of an element or atom. And so you can guess that since the mass of C12 and C14, that's the only difference, that means there's a different number of neutrons in between. So those are isotopes. Isotopes have a different number of neutrons, but it's the same element. And so hence, because they have a different number of neutrons, they have a different mass from each other. And so that's basically it for atoms and isotopes and ions and electrons, protons, and neutrons. And so I hope you learned well today. and practice these with some free worksheets that you can find online. If you just type in electrons, protons, neutrons, and ions free worksheets online, you can find some free worksheets. And I hope you learn more and have a good rest of your day. Thank you for watching. Please like and subscribe. See ya.